Hello, students who are joining us. I don't know if it's morning, afternoon, or evening, but either way, hello. Today we're going to be covering section 5.12 energy levels. And remember, it is the same topic that you have on CK12. And we're more than likely not going to get to finish this topic. It is a very long and lengthy topic. There's a lot of things that we need to discuss. So this is probably going to be a part one. Okay. Part two will be done on Monday, part two. And I think it's just really a video. Okay. So I don't know if I'll actually record it, but if not, I should record it. So either way, don't worry about it. All right. Let's get started. Who is going to help me fifth period? And I am working with fifth period. Thank you, fifth period. Can you guys help me out with the introduction? Oscar, is that you? Hello? Is anybody out there who wants to help me with the introduction? Yeah, Alexia, what about you? Hello? Is anybody out there? Oscar, are you there? Yeah, Alexia?
Hello.
Can you help me with the introduction, Oscar?
Yeah. Fireworks are a great way to celebrate happy events. Do you know what causes the brilliant colored lights of fireworks? The lights are bursts of energy given off by atoms in the fireworks. What do you suppose causes these bursts of light? The answer has to do with energy levels of atoms.
Thank you, Oscar. And I totally get you. Yeah, Alexia, you did help me all week. All right. So, anytime you see a firework go up and explode into these beautiful colors that they release, it's basically different types of elements. Okay, different types of elements. When you heat them up with enough energy, electrons jump energy levels, to be specific. We call those, they have a special name. It's called quantum leaps, right? Anytime you an atom gains energy, it will cause electrons to jump energy levels, and that's what we call quantum leap. So they have electrons absorb that energy that was fired away at it, and as it absorbs energy, it will make that leap to a higher energy level. Now, electrons cannot hold on to that energy for very long. Okay, it's only a short amount of time. So they will eventually drop back into its original energy level. And as they do that, they will release the energy they absorbed. And it's usually in the form of a bright light. Okay, and that's what you see on New Year's. That's what you see during the 4th of July weekend. Or in our case, in the island, just about every weekend during the summer break, right? They always have a fireworks display. So, what are energy levels? What are energy levels? That's the topic for today. Energy levels are also called electron shells, okay? Electron shells. This is where you find these electrons rotating around the nucleus, okay? Energy levels is what they're actually called, or you can call them electron shells. Energy levels are fixed distances from the nucleus of an atom where electrons may be found. So each energy level has a specific distance from that separates that energy level from the nucleus. Okay, and then the second energy level will be another a certain distance, and then so on and so on. You have to remember, electrons are very small. They're tiny. They're negatively charged particles in an atom, and they move around that positive nucleus that's at the center of the atom. Energy levels are like steps on a staircase. You can stand on one step, or you can stand on the next step, but you can never stand in between. The same goes for electron. An electron can be an energy level 1, 2, 3, 4, and so on, but it cannot be in between energy level 2 and energy level 1. It's either an energy level 2, energy level number 1, or any other energy level, but it cannot be between the energy levels, okay? And here you have a picture of what an atom looks like. In the center, you have your nucleus with a positive charge. And then you have the first 4 energy levels, okay? And these energy levels are numbered 1, 2, 3, and 4. Or you can call them by letter K, L, M, or N. Now, the numbers that you see at the top of this picture represent how many electrons maximum it can hold. Okay, it can hold less than these numbers, but never more than these numbers. Okay, so for energy level 1, it's 2. For energy level number 1, you have 2 electrons. Energy level number 2, you have 8 electrons. Number 3 will hold 18, and number 4 will hold a maximum of 32 electrons. Okay. And energy levels cannot form unless a lower energy level has been completely maxed out. Okay, I will not have energy level number 2 until I have 2 electrons in energy level number 4. Same thing for energy level 3 and energy level 4. They cannot form until those lower energy levels max out. Once it maxes out, then another electron will form that third energy level or that fourth energy level. Okay, so you have a couple of fill in the blanks. So you're going to be writing a response. You have 3 responses that you're going to give me. So the first one, the first sentence says, energy levels are also called blank. What is that second name for energy levels? And then you have another sentence that has 2 blanks. They are fixed distances from the blank of an atom where blank may be found. Okay, so what do we find in energy levels? And then what are they? How, it says that there's a fixed distance from something of an atom. So what do you think, guys? Do you guys remember? What goes in these blanks? What goes in these blanks here? So energy levels are also called something, okay, are also called blank. What is another name for energy levels? And they are a certain distance away from that center. What is that center of an atom? What do we call it? And what do we find in energy levels? What's floating around in these energy levels? What are these dots represent? Okay, so that's for that last one. The center of an atom. What is the center of an atom called? And then this one, you got to know it in order to, there's really no hints for it. Okay, so can we at least figure out 2 out of the 3? 1 out of the 3? Or can you figure out all 3 blanks? 1 person has responded. What about the rest of you guys? If you are not in Pear Deck, you should be telling me what you think goes in these blanks. And it doesn't matter if it's wrong. Just try and take a guess at what you think goes in those blanks. You have your packet, the answers are there. But I don't know how many of you guys have your packet. Mm-hmm. 2 out of 5 people have responded. Let's check out their answers. Maybe they're still typing, maybe they're not. Okay, 1 person said electron shells. Good. Somebody else said outer shell and then nucleus. Okay, nucleus, yes, that's one answer. Electron shells is another answer. And nobody has figured out that last one. Which one is you? Write your name for you. Okay, so energy levels are also called electron shells. Very good. They are fixed distances from the nucleus. Very good. Somebody else gave me that one. But nobody has come up with that last blank. Okay, they are fixed distances from the nucleus of an atom where blank may be found. Oscar, you answered in 2 different responses. Okay. Okay. What can I found? What can I find in these energy levels? What are these dots represent? What do these dots represent? Anybody know? What is outside of the nucleus? Nobody remembers what's outside of the nucleus. What is the cloud made of? What are these energy levels holding? It's kind of part of the first answer that Oscar gave me. It's part of that first answer you gave me, Oscar. What can I find in these energy levels? What can I find in these energy levels? Anybody else? Isael, Yaslin, Mario, Hania?
So I gave you 2 right answers.
Yeah, you gave me electron shells. That's 1. You gave me nucleus. That's 2. But the answer for the third one is in this first. It's in there. In that first answer you gave.
Electrons.
Very good. Electrons. There are fixed distances from the nucleus of an atom where electrons may be found. Excellent. Energy levels. Electrons in energy level number 1, also called K, have the least amount of energy. So any electron in energy level number 1 has low energy. Okay? As you go farther from the nucleus, electrons at higher levels have more energy, and their energy increases by a fixed amount, and it doesn't say how much. So when it comes energy-wise, K, energy level number 1, is known as any electron in here is low in energy. If we're talking about energy level number 2, that's like saying electrons have medium energy. If you're talking about energy level 3, electrons here will have like a medium high energy. And if you're in energy level 4, you have a very high energy. Okay? So low energy electrons, you have here, and electrons with low energy, electrons with medium energy, electrons with medium high energy, and then over here in the 4th energy level, that's where you have electrons with a high amount of energy, the highest. Okay? The further you are from the nucleus, the more energy you need in order to be in that outermost energy level. Electrons can jump from a lower to a higher energy level if they absorb energy. On the other hand, opposite, if electrons jump from higher to lower energy, they give off energy, often in the form of light. Okay, so an atom gets hit by a certain amount of energy. Electrons will do quantum leaps to higher energy levels. Now, they cannot stay there. Eventually, they have to let go of the energy they absorbed, and when they let go and release it, they go back to that original energy level that it was at. And when it does that, when it releases the energy, it's usually in the form of light. And that's how come you see different colors for different elements, okay? Different elements give off different colors. This explains the fireworks picture over here on the side. When the fireworks explode, electrons gain energy, jump to higher energy levels, When they return back to the original level, they release the energy as light. And like we said, different atoms, different elements have different arrangement of electrons, so they give off different light, different colors of light. All right, drag your red dot. Drag your red dot to the energy level where you find electrons that have the most energy. Very high energy electrons. Where am I going to find that? Energy level 1, 2, 3, or 4. Okay? Where can I find electrons with the highest energy, with the most energy? Energy level 1, 2, 3, or 4. Where are you going to put that red dot, guys? Where are you going to put the red dot? Are you going to put it here on energy level 1, here on energy level 2, here on energy level 3, or over here on energy level 4? You tell me. What do you think? Yeah, Alexia, where would you put your dot? Efrain, where would you put your dot? Yoslin, where would your dot go if you had to pick an energy level where electrons have high energy? What do you think? Where would you do that? One person has responded in Pear Deck. Okay, what about my other 5 students that are in there? Where are my other 5 students dragging their dots to? Come on, guys. Participation counts. If you are not participating, don't expect extra credit. Two people have responded. Okay. But I have a lot more students here than just 2 students. 3 people have responded. Excellent. If you want to join me in Pear Deck, there's your link. All right. Oh, look at this. I got 2 dots on energy level 4, 1 dot on energy level 3, and then I got another dot that's somewhere other than the atom or the energy level. All right. Are you ready? Are you ready? I can't do a drum. Energy level 4 is where you will find electrons with high energy. Thank you. Very good. We got 2 students who chose the correct energy level. Very good. Energy level 4. Great job, guys. Energy levels and orbitals. The smallest atoms are hydrogen atoms. They have just 1 electron orbiting the nucleus. That 1 electron is in the first energy level. Bigger atoms have more electrons. Electrons are always added to the lowest energy level first until it has a maximum number of electrons. Then electrons are added to the next higher energy level until that level is full, and so on and so on. Okay? I cannot form energy level 1 and 2. I have to form 1, fill it up, then the second energy level will form, fill it up, then the third energy level will form, fill it up, and then the fourth energy will form. Okay? You cannot form more than 1 energy level until you fill the lowest one first. How many electrons can a given energy level hold? Okay? The maximum number of electrons possible for the first 4 energy levels is shown in the figure, and we already talked about it, right? We said 2, 8, 18, and 32. And it says, for example, energy level 1 can hold a maximum of 2 electrons. Energy level 2 can have a maximum of 8. The maximum number depends on the number of orbitals at a given energy level. An orbital is a volume of space within an atom where an electron is most likely to be found. As you can see by the image in the figure below, some orbitals are shaped like spheres, right? It looks like a basketball around the nucleus. And that's where you can find electrons. Some orbitals are shaped like dumbbells, okay? And that's known as a p orbital. There are other types of orbitals as well, but their shapes are a lot more complicated. Okay, so here you have an example of what an s orbital looks like. Kind of looks like just a basketball around the nucleus. For your p orbital, I always think that they look like a infinity sign, side to side, or a figure eight that's side to side rather than up and down. That is a p orbital. It doesn't matter the shape of the orbital. Each orbital can only hold a maximum of 2 electrons. Okay? S orbitals, p orbitals, all of them hold 2 electrons for each orbital. Okay? So if you want to know how many orbitals are in each energy level, all you need to do is take the number of electrons it can hold and divide it by 2. So for energy level 1, 2 divided by 2, 1 orbital. Energy level number 2 has 8 electrons. 8 divided by 2, it will have 4 orbitals. And then so on and so on and so on. Here you have another question, students. It says energy level 3 can hold a maximum of 18 electrons. So 18 max. How many orbitals does this energy level have? Enter a number. So you got to type in a number. How many orbitals for energy level 3? So always think, okay, well, what is the maximum number of electrons per orbital? Once you know that, you take 18 divided by that number, and it will give you how many orbitals for energy level 3. Check it out. No responses yet. No responses. Hello, anybody out there? 18 electrons in energy level 3. How many orbitals? How many orbitals?
3.
Okay, so we got Yoslin who says there's 3 orbitals. Anybody else have a different one? Have a different answer before I give out the correct answer? All right, 2 people have responded. Let's see what they think. All right, I got a couple of dots. One of them is between 15 and 20. I got a 10 and 11. And then there's another dot over here between 0 and 5. I don't really know. Okay, so somebody's saying 11. There are 11 orbitals in energy level 3. Okay, so let's go back. Remember, if you go back, it says here on the box over here on the bottom, regardless of its shape, it doesn't matter if it's a P, an S, or a D, or an F. Each orbital can hold a maximum of 2 electrons. So if you're talking about energy level 3, 18 divided by 2, how many orbitals does that energy level hold? 18 divided by 2, guys. What's 18 divided by 2? How many orbitals does this energy level hold? Anybody? 18 divided by 2, guys. 18 divided by 2. What's the answer? What's 8? Yes? 18 divided by 2, Yoslin, do you know?
9.
9. Thank you. Yes. 18 divided by 2 is 9. There are 9 orbitals in energy level 3. Very good, America. Good job, mija. Electrons in the outermost energy level of an atom have special significance. Those electrons are special. Electrons in the last energy level. If you have electrons in that outer energy level, those are special because those are the electrons that are available to be lost, shared, or gained. Okay? You can either gain electrons, lose electrons, or share electrons. And they have a special name. These are called valence electrons. And we've been talking about valence electrons for a while now. Okay? We defined it not too long ago. Valence electrons are in the outermost energy level. These are the electrons to be lost, gained, or shared. They also determine how an element reacts. So it does tell us properties of that atom. An atom is most stable if that outermost energy level contains as many electrons as it can hold. For example, helium. Helium has 2 electrons, both in the first energy level. Well, according to what we know from the last couple slides, energy level number 1 can only hold 2 electrons. So if you have the maximum number of electrons for that energy level, you are considered a stable atom, and you're not going to want to react with anybody else. You're not going to want to lose. You're not going to want to gain. You're not going to want to share. Why? Because your energy level, the last one, the outside one, is considered full. And for energy level number 1, the maximum you can have is 2. So helium is one of those special atoms that doesn't like to react because it has a full valence shell, a full outer shell, energy level. Electrons in the outermost energy level of an atom are called what? Are called blank. What is the name of electrons in that outermost energy level? Okay, anybody remember what those electrons are called? They have a special name. What's it called? I'll give you some time to think. Write your response, guys. Starts with the letter V. What is the name of those electrons? We got a special name to them. Anybody know? 2 people have answered. Let's see.
Valence electrons?
Yes, ma'am. Valence electrons, however you want to say it, that is correct. That is correct. Good job. I'm assuming this is Oscar and somebody else. Good job, Yalexia. Good job, America. That is correct. So let's talk about some elements. Let's talk about fluorine and lithium and their valence electrons. So fluorine has 7 out of 8 possible electrons in its outermost energy level, which is energy level 2. It would become more stable if it had 1 more electron because it would fill energy level 2, right? It can hold a maximum of 8. Lithium, on the other hand, has just 1 out of 8 electrons in the outermost energy level. It would become more stable if it had 1 less electron because it would have a full outer energy level, which would be considered energy level 1. All right, so fluorine is in group 17. Lithium is in group 1. Every element on group 17 will have 7 valence electrons. Every element in group 1, lithium, sodium, potassium, has 1 valence electron. So when it comes to group 17, They're always telling everybody, they're always saying, hey, is anybody out there who wants to give up one electron? I need one electron. Anybody want to give it up? Anybody want to share with me? And group 1, on the other hand, on the opposite end of the periodic table, well, he has one valence electron. So group 1 is saying, hey, anybody want this electron? I don't need it. It's better if I get rid of it. Anybody interested? Anybody? And more than likely, well, if you got these two elements and they're kind of close to each other, you're going to see what's going to happen. Look at what happens. Group 1 and group 17 are considered highly reactive elements. Both fluorine and lithium are considered highly reactive elements because of their number of valence electrons. Fluorine easily gains one electron. Lithium will easily give up one electron to become more stable. In fact, lithium and fluorine will react together as shown in the figure. When the two elements react, lithium transfers its one electron to fluorine. So, group 17, fluorine, and all those other elements, they usually gain. They're always looking for one electron. Group 1 usually wants to give it up. So, group 17 and group number 1, they work well together. They work well together. All right, guys, this is where we're going to stop. We don't have a lot of time. This video is a 9-minute video. We're going to stop here. We're going to continue on